Water and Oceans, chapter number 13. So, the presence of water in different water bodies in the decreasing water. Most of the water on the earth's surface present in the oceans, and it is 97.25% approximately. Then in the ice caps, then in the groundwater, then lakes, then soil moisture, then atmosphere, then river and biosphere. Next point: relief of the ocean floor: Pacific, Atlantic, Indian, and Arctic. Rugged with mountains, trenches, and largest plains. Reef of the ocean floor is rugged with mountains, trenches, and largest plains. It is present in Pacific, Atlantic, Indian, and Arctic oceans, or in other seas as well. Division of the ocean floors: four divisions. First, continental shelf, then continental slope, then deep sea plain, then oceanic deeps. Continental shelf: shallowest part of the ocean, ends at a very steep slope called the shelf break. Absent in continental shelf is absent in Chile, west coast of Sumatra, etc. Largest is Siberian shelf in Arctic. Then continental slope. Continental slope connects continental shelf and ocean basins. Generally gradient of 2 to 5 degrees. Continental slope. A slope boundary indicates the end of continents. Canyons and trenches are observed in these regions. So canyons and trenches are observed in the continental slope region. Deep sea plain, also called as abyssal plains. So gently sloping areas of the ocean basins, flattest and smoothest regions of the world, fine-grained settlements like clay and silt. Then come the oceanic deep or trenches, deepest part of the oceans. Trenches are relatively deep-sided, narrow basins at bases of continental slopes and along island arcs, and are associated with active volcanoes and strong earthquakes. Minor relief features. Next point is minor relief features. So the first point is mid-oceanic ridges, two mountain chains separated by a large depression, for example in Iceland. Then the seamount. Seamount are basically of volcanic origin. Example, Emperor Seamount, an extension of the Hawaiian Islands. The next point is submarine canyons. These are generally deep valleys, sometimes cutting across the continental shelves and continental slopes, often extending from the mouths of large rivers. Example, Hudson Canyon. The next point is guyards, flat-topped seamount. Then next point is atoll, low islands found in the tropical oceans consisting of coral reefs surrounding a central depression, may be a part of sea, that is lagoon, enclosing fresh brackish or saline water. Then next point is temperature of ocean waters. Factors affecting temperature distribution. First is latitude, generally on the surface. Then second is unequal land and water distribution, factors affecting temperature distribution. And third is prevailing wind. Wind from land to sea drive warm surface water away, thus upwelling of cold water from below. It results into the longitudinal variation in temperature. Onshore winds pile up warm water near the coast. Then the fourth point is ocean currents. For example, Gulf Stream is a warm current and the Labrador is a cold current. Labrador is near the northeast coast of Northern America. Then enclosed seas in low latitudes have relatively higher temperature than open seas and vice versa. The next point is horizontal and vertical temperature distribution. The first point comes the thermocline. The boundary region from where there is a rapid decrease of temperature is called as thermocline. Next point. Temperature structure of ocean over middle and low latitudes can be described as a three-layer system from surface to bottom. The first layer, top warm layer, and is 500 meter. Top warm layer and is up to the depth of 500 meter. In tropics, it is present throughout the year. In mid latitudes, develops only during summer. Second layer is thermocline from 500 to 1000 meter, and the third layer is cold up to the ocean. Third layer is cold layer up to the ocean floor. So in the Arctic and Antarctic circles, the surface water temperature are close to 0 degrees Celsius, and so the temperature change with the depth is very slight. Here only one layer of cold water exists, which extends from surface to deep ocean floor. Next point, highest temperature is not recorded at the equator but slightly towards north of it. Next point, heat transfer to lower sections through the process of conduction. The heat transfers to lower sections through the process of conduction. The next point is temperature falls rapidly up to 200 meter, and therefore the rate of decrease of temperature is slowed down. And thereafter, temperature falls rapidly up to 200 meter, and thereafter the rate of decrease of temperature is slowed down. The next point is salinity of ocean waters. So the first point is salinity is calculated as amount of salt in grams dissolved in 1000 gram of seawater. Salinity, next point is salinity of 24.7 parts per thousand ppt has been upper limit to demarcate brackish water. So what is upper limit of brackish water? 24.7 parts per thousand. So factors affecting salinity. First, surface, evaporation and precipitation. Second, surface on the rivers, pools, freezing and thawing of ice. Third is wind. Fourth is ocean currents. Salinity, temperature and density of water are interrelated. Hence, any changes in the temperature or density influences the salinity of an area. Next point. Lake Van in Turkey has a salinity of 330 parts per thousand. Then Dead Sea has 228 ppt. Then Great Salt Lake has 220 ppt. So the decreasing order of the various minerals present in the saline water. So the largest concentration of so the chlorine is in the largest concentration. Then comes the sodium. Then comes the sulfate SO4. Then comes the magnesium Mg. Then comes the calcium Ca. Then potassium K. Then SCO3. Then bromine Br. Then borate. Then structures. Then borate. Then I don't know what is this. Up to the borate. Then next point, horizontal distribution of salinity. First point, normal open ocean 33 to 37 parts per thousand. Landlocked Red Sea has 41 parts per thousand. Estuaries and Arctic Sea has 0 to 35 parts per thousand salinity. So the next point, the North Sea, in spite of its location in the higher latitudes, records higher salinity due to more saline water brought by the North Atlantic Drift. So why North Sea, in spite of its location in the higher latitudes, have more salinity? So because more saline water brought by the North Atlantic Drift. Baltic Sea records low salinity due to influx of river waters. Mediterranean Sea has high salinity due to high evaporation. Black Sea has less salinity due to the rivers. Indian Ocean has the salinity of 35 parts per thousand. Bay of Bengal has low salinity due to the presence of rivers. Arabian Sea has high salinity due to the less river and more evaporation. Then the last point.